Good morning, grade 9 students, and welcome to another lesson. Today, we are going to study about the second law of motion, also known as the law of acceleration. Are you ready? For our intention, competency, investigate the relationship among force, acceleration, and mass. And for our objectives, at the end of the lesson, learners will be able to, number 1, state Newton's second law of motion. Second, explain the relationship among force, mass, and acceleration. Third, solve simple problems involving force, mass, and acceleration. And lastly, appreciate the importance of force and mass in everyday activities. Before we start our lesson, we're going to have an unlocking of difficulties. It is a push or a pull. Its sources may be gravitational, electrical, magnetic, or simply muscular effort. So the answer is force. Second, it is a change in motion produced by a force or combination of forces. So the answer is, you got it, it's acceleration. Lastly, it is the measure of the total amount of matter or stuff contained within an object. Okay, so the correct answer is mass. For a moment, think about it. How do you feel when pushing an empty cart? Pushing an empty cart is easy. You give it a tiny push and zoom, it moves away. But once you load that cart with heavy sacks of rice or canned goods, suddenly that same tiny push does nothing. You have to push harder just to get it moving. So we have a question. Why does the empty cart speed up so fast, but the heavy cart barely moves? The answer lies in Newton's second law, the law of acceleration. To understand the law of acceleration, we are going to have a learning experience titled Faster and Faster. Consider that the mass of the crate is constant. Which crate will accelerate faster? And why? So as you can see from the picture, one crate is pushed by many people and then the other crate is pushed by only one person. Considering that the mass of the two crates are the same, which crate will accelerate faster and why? So obviously, the crate pushed by many people accelerates faster because at constant mass, greater force results to higher acceleration. This time, let's look at these images. Consider that the man exerts the same force on the wooden cart with different mass. Which will accelerate faster and why? Correct. The one with lesser mass will accelerate faster because at constant force, acceleration increases as mass decreases. So from the activity, we learned the Newton's second law of motion, which states that acceleration is directly proportional to force and inversely proportional to mass. To make it simpler for you to understand, let's break it down into two parts. First, direct proportionality. So force and acceleration have direct proportionality. Greater force results to greater acceleration, and lesser force means less acceleration. For example, when you pedal on your bike and you apply lesser force, it will result to lesser acceleration. But when you apply greater force on the bike pedal, it results to greater acceleration. Second is inverse proportionality. It means that when one value increases, the other value decreases, and vice versa. So mass and acceleration have inverse proportionality. Greater mass results to lesser acceleration, and lesser mass results to greater acceleration. For example, When you push a motorcycle that has lesser mass, it results to greater acceleration. But when you push a car with greater mass, it results to lesser acceleration. So, if you want maximum speed or acceleration, you have two choices. First, make the engine stronger. That is, by increasing the force. Secondly, make the car lighter or decrease the mass. Mathematically, the law of acceleration states that the acceleration equals the net force acting on an object divided by mass. So here is the formula. A equals force over m. Meaning, in order to get the value of acceleration, we will divide the value of force over the value of mass, or force equals mass times acceleration. Sample problem. A soccer ball has a mass of 0.5 kg. If a player kicks the ball with a net force of 10 Newton, what is the acceleration of the soccer ball? So, to solve the problem, we need to identify the given values. First is the mass, that is 0.5 kg. Next, the force is 10 Newton. And the missing is acceleration. Second, we state the formula. A equals F over m, where A stands for acceleration, F stands for force, and m stands for mass. Third is the solution. So we substitute the values to our formula. A equals, the force is 10 Newton, and the mass is 0.5. So we will divide 10 divided by 0.5. If we divide them, it will result to acceleration equals 20 meter per square second. So by the way, the unit of acceleration is meter per square second. The acceleration of the soccer ball is 20 meter per square second. This time, it's your turn. Grab your notebooks and your pen. Solve the following problems. A student is standing on a skateboard with a combined mass of 50 kg. If a friend pushes them with a force of 25 newtons, what is the student's acceleration? Are you done solving? So the correct answer is, the acceleration of the student riding on the skateboard is 0.5 meter per square second. Second problem. A student pushes a heavy box across the floor with a force of 50 newtons. The box accelerates at a rate of 5 meter per square second. The question is, what is the mass of the box? So the correct answer is, the mass of the box is 10 kilograms. Now let's wrap up Newton's second law. First, acceleration is reduced when an unbalanced force acts on a mass. Second, direct relationship. The greater the force, the greater the acceleration. Next, inverse relationship. The greater the mass, the less the acceleration. Next, the formula that we should all be familiar of is force equals mass times acceleration, or acceleration equals force over mass. Now, grab your pen and your notebooks. It's time for assessment. Number 1. According to Newton's second law, if we apply the force to a tennis ball and a bowling ball, which one will accelerate faster? A. The bowling ball. B. The tennis ball. C. They will have the same acceleration. Or D. Neither will move. Number 2. What is the mathematical formula for Newton's second law? A. Force equals mass over acceleration. B. Mass equals force times acceleration. C. Force equals mass times acceleration. Or D. Acceleration equals mass over force. Number 3. If you want to increase the acceleration of your bicycle, what should you do? A. Pedal with more force. B. Stop pedaling. C. Add heavy bags to the bike. Or D. use a heavier bike. Number 4. Acceleration is defined as a change in A. Mass only, B. Color, C. Speed and or direction, or D. Shape. Number 5. A truck has a mass of 3,000 kg and a small car has a mass of 1,000 kg. If their engines produce the exact same force, which vehicle will speed up faster? A. The truck, B. Both will not move, C. Both have the same acceleration, or D. The small car. And lastly, solve the following problem. For 5 points. You push a toy car that has a mass of 2 kg. If you push it with a force of 10 newtons, how fast will it accelerate? It's time to check your assessment. Here's the answer key. Number 1. The correct answer is B, the tennis ball, because it has less mass, therefore more acceleration. Number 2, correct answer is C, force equals mass times acceleration. Number 3, the correct answer is A, you pedal with more force, because when you increase force, you increase the acceleration. Number 4, correct answer is C, speed or direction. Number 5, the correct answer is B, the small car. Less mass means it accelerates easier. And for the problem solving, the toy car will accelerate at 5 meters per square second. And for your race forward, research one example where Newton's second law is important in transportation, sports, and space exploration. See you next lesson! Remember, whether you are pushing a cart or chasing your dreams, if the load is heavy, just apply more force. Thank you so much for watching and for your support. Please like and subscribe to Sir Dom's blog. Thank you!